Okay, today's key concept on worksheet 14 is about the trigonometric functions of general angles. This is on your worksheet 14A. This is just another way of describing the trig functions that we've already talked about as far as the right triangle trig and set opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent for the tangent. And then we're going to apply that with our new three trig functions that are the reciprocal functions of those. So I'm going to redraw a little picture here on the side. And what's going to be important is learning how to find a reference angle. So all I'm doing is redrawing what they have here. And what's gone on in that picture is theta was actually an angle that came from here all the way to here. Can we close the door? Thank you, Celeste. Okay. There's a little problem in the hallway, just a moment. This right here is going to be called your reference angle for theta. Some books use a little hat symbol, sort of, I call it a hat, over it to represent the reference angle. Or this book sometimes uses a little tick mark or prime notation. So this is actually theta. It's actually, remember, it comes off the positive x-axis all the way around. So all I did was blow up this picture. Now, if you were talking about a circular function, the radius would be here, and this would be your x value, and this would be your y value. And if you remember, do you remember vectors back in geometry? You had the terminal point of your vector was the end of the vector, and that was your point x, y. It's much like that. So this would be the length of that. And it turns out that in this little figure that we kind of drew, we drew this little perpendicular to the x-axis. This little right triangle can help us find the value of the 6 trigonometric functions of theta. You have to use this reference angle, so and you have to know what quadrant you're in. Okay, and the quadrant is important to know, like, say, whether it's positive or negative, etc. For this particular diagram, the sine of theta is y. You can even think of it again as opposite over hypotenuse, y over r. Now that we have it labeled this way, cosine of theta, adjacent over hypotenuse, x over r. Tangent of theta, y over x. Okay, so we're just doing a new definition for the same thing we've been doing. All right, so with that in mind, let's just move on to how to do these type of problems. The terminal side of theta in standard position contains each point. You want to find the exact values of the 6 trigonometric functions of theta. I know you laugh at me the way I say that. Okay. Oh, it's a pretty cool word. Trigonometric. We are having the point 5, 12, and that would, where would that land us? What quadrant would 5, 12 be in? If you think about plotting that point, yeah, it'd be quadrant 1. So I'm going to draw, since it is a positive and positive, we'd be in quadrant 1. So I'm just going to sketch a little vector, and I'm going to act like, hey, there it is right there. That's the name of it. Okay, and I'm going to drop from the tip of it straight down to the x-axis, forming a little right triangle. The 5 is the x value, would be the horizontal value, and 12 is the vertical value. And theta would actually be its own reference angle because it's in the first quadrant. So it's positive, that's where theta is. To find the sine of theta, we also need to find the value of r. And from this idea of back to circles even, remember how x squared plus y squared equaled r squared? That was a standard form for a circle with the center at 0, 0. This applies to that too. So many things are connected to the same ideas. So it's not really all that new of a stuff. It's just worded in a different way right now. So as we look at x squared plus y squared equals r squared, we're just basically doing the Pythagorean theorem to find r here. So that would be 5 squared plus 12 squared equals r squared. And 5 squared plus 12 squared is 169. You take the square root and you will find that r is, the square root of 169 is r, and that's 13. So I can write down here x equals 5, y equals 12, r equals 13, and then I can start writing my trig ratios. sine is y over r, or you can look at your little figure and just do it from there. You can replace the r with the 13 and say opposite over hypotenuse. That's going to be 12/13. The cosine would be 5 over 13, and the tangent would be 12 over 5. Any misconceptions about where I'm getting, or misunderstandings of where I'm getting these answers? Guys, no. All right, and then our reciprocal functions, the sine and cosecant are reciprocal functions, so cosecant is going to be 13 over 12. Secant and cosine are reciprocal functions, so secant is going to be 13 over 5. And tangent and cotangent are reciprocals of one another, so that's going to be 5/12. Okay. All right, for number 2, 3, 4 would also be, you know what? That would be in quadrant 1 also, so I think we can really go fast through this one. We've got x equals 3, y equals 4. What is r going to be? How do you know it's 5's less? Okay, so you already did that quickly? Okay, and what quadrant are we going to be in? Yep, 1. Good. You might remember a 3, 4, 5 Pythagorean triple, where 3 is your x value, 4 is your y value, and the hypotenuse would be 5. 3, 4, 5 Pythagorean triple. Yeah, because we're in quadrant 1, so we're kind of lucky right now. We're just in quadrant 1. All right, so sine, of course, is going to be 4/5, cosine's 3/5. I'm going to go real fast now on that, and the tangent is 4/3. And then cosecant 5 over 4, secant 5 over 3, and cotangent 3 over 4. All right, so let's get to something with a little more meat. On number 3, we now finally have something that's not in quadrant 1. If I'm going to go right 8 and down 15, that's going to put me in quadrant 4. Yep. And I don't really care if we draw that to scale. Just get yourself a little triangle. Your reference angle is right here with the x-axis. Okay. The angle actually of theta would really be, this is the reference angle. It's actually here all the way to there. Okay, it would have been an angle over 270. Does that make sense? Or a negative angle. All right, now, 8 is your x value, negative 15 is your y value, and the r is always positive. So if we do x squared plus y squared equals r squared, we're going to get 64 plus 225, which is 289. Take the square root, and we get r is 17. All right, with r being 17, we'll just go through our 6 trigonometric functions of theta. So sine, negative 15 over 17. Absolutely. Negative 15 17ths. Then why don't I just flip it over right now? And that would be negative 17 15ths for the cosecant. And we kind of have these ordered nicely for you. The cosine would be 8 over 17, and that one's positive. And the secant would be 17 over 8. And the tangent would be opposite, negative 15 eighths, or negative 8 15ths for the cotangent. All right, the next one is actually going to have some radicals in it. We're going to have a lot more work to do to get these simplified, but if you'll stay with me, I'm going to try to make it as easy as possible. Okay, so let's go ahead and find r. 68, negative 8 squared would be 64, plus 144 for y squared. When I add those, I get 208. And I have to take, r would be the square root of 208. I know that's kind of the work that some of you do instead of writing all this equation out. We need to simplify this. So how do you decide what perfect square divides evenly into 208? If that hasn't been the easiest thing for you, you might want to take your calculator and take 208 and then just start thinking about numbers. I know one of them might be 4 because it looks like it would be divisible by 4. Do you see what I'm saying? But it might not be big enough. So if you try dividing by 4 again, that'll tell you that it's 16 times 13, okay? Since it went evenly by 4 twice. So this breaks down to 16 times 13, was it? Right? So that's 4 square roots of 13. 4 root 13. All right, now, before you write anything in these blanks, let's do the sign kind of below here to give you a little bit of an idea of how to simplify it, or if you have, it's not a whole lot of room I see on this paper, but there's a bunch down here on that side on your paper. All right, sine is y over r, so that would have been 12 over 4 root 13. Now, let's reduce this first, okay? 4 goes into 12 3 times. So this would be 3 over the square root of 13. Now, I'm not going to rationalize it yet. You do have to. I'm going to flip it over to get the cosecant first. I'll do the reciprocal of that, and then I won't have to mess around with that whole. That'll be really messy if I try to flip over after I rationalize it. So this is the best way to do it, is before rationalizing these, write the cosecant, the reciprocal function. Okay, cosine would be x over negative 8 over 4 square root of 13. That's going to reduce to negative 2 over the square root of 13. Okay, so I'm going to flip that over now to get the secant. So that's going to be negative square root of 13 over 2. Okay, and then the tangent, oh, that's going to be simple because that's going to be y over x, 12 over negative 8. And I'm going to simplify that right now by reducing, dividing by 4 top and bottom, we get negative 3 halves. So the cotangent would be negative 2/3. Okay, now go back and rationalize your denominators. You multiply top and bottom by the square root of 13. I think we've done this possibly enough that we'll know it's 3 square roots of 13 over 13. Is that too fast for me? You want me to show you how I got to that? Okay, right. When you have 3 over the square root of 13, to rationalize it, you multiply the top and the bottom by the radical. Okay, so now I've got 3 root 13 on top. Square root of 13 times square root of 13 is 13. And it doesn't reduce, so because we already did our reducing. If it should reduce, you must. So then the cosine would be, I'm going to now rationalize that. Okay, so that would be multiply top and bottom by the square root of 13. My pen's, oh, hold this back. I have a little spasm in my smart notebook. Okay, so then you multiply this one and get negative 2 square roots of 13 over 13. Okay? Okay, that's one way to say it. I'll just refrain. I thought I could skip 5 with you. Do you? That's going to be a nice R value of 41. All right, so you're just going to write a bunch of fractions. So in order to give a little more time to the harder stuff, I'll move on to number 6. 6 will go pretty quick. X is 1, Y is 2, and R, if you're going to take 1 squared plus 2 squared, that's 5, and so that would be the square root of 5. All right, so the sign is 2 over the square root of 5. Before you rationalize it, write the reciprocal function, which is the cosecant, square root of 5 over 2. Okay, and the cosine would be 1 over the square root of 5. So that makes the secant the square root of 5. And the tangent, of course, is y over x, so that'd be 2 or 2 over 1, and the cotangent would be 1/2. Go back and rationalize the sine and cosine. So you're going to multiply top and bottom by the square root of 5, giving you 2 root 5 over 5 for the sine. Multiply top and bottom by the square root of 5 on the cosine, giving you the square root of 5 over 5. All right. Now this one would have been in quadrant 3. Yes. Which one's going to be positive then? Tangent and cotangent. And I'll show you that shortly, a little way to remember that. Now, first though, we want to talk about quadrantal angles. Quadrantal angles are angles that land on the x or y axis, okay? So this 0 degrees here, if you want to think of it as the point r theta, meaning isn't r the x value now, the radius or the length of that ray? It's now just r. So the cosine and sine can be found by thinking about this. The sine of 0 degrees would equal the y value, 0, over r, which would be 0. The cosine of 0 degrees would be the x value, r, over r, which would be 1, using this point that's given to us on this x-axis. If we go up to 90 degrees, then you got the point 0r. And since sine we learned to be, remember, okay, sine was equal to y over r, cosine was x over r in our new format. And I guess I should put a theta there, but whatever. All right, so here, the sine now of 90 degrees, or pi over 2, is equal to y, now is r, over r, which would be 1. And the cosine at 90 is going to be x over r. 0 divided by r would be 0. Do you understand why I'm having r twice? Because that point has r as the y value, right? The next one, this would be the sine of 180. Well, now it's negative r because you went left. The radius of it, or the length of that vector would be negative to the left. So sine of negative 180 would be y, 0 over r, and that would be 0. And the sine of cosine, excuse me, of 180, let me erase that. The cosine of 180, what do you think? I'm going to quit writing this over r thing. Negative r over r would be negative 1. What you need to know for quadrantals is sine and cosine are 0 or 1 or 0 and negative 1 all the time. When I get to 270, the sine at 270 is negative 1 and the cosine is at 270, 0. Does anybody still need this? Either of you guys? Okay. Now, the next concept is where we're starting to really get into some new stuff. Reference angles. A reference angle is an angle made with the x-axis. It's the angle made with the nearest x-axis, as opposed to what theta is. Theta, the angle itself, can be large, out of the range of 90 degrees. It can be all the way into 180, 270, etc. Or even larger than 360. If you want to find the reference angle, you have to figure out where theta terminates, and then find the closest x-axis to it and find out that measure. So if your angle is in quadrant 1, terminating in quadrant 1, then the reference angle is right there. It is the actual theta itself. Okay, so if theta is between 0 and 90, theta reference is equal to theta. I usually like to use a little hat thing. And I'm going to summarize all this in a moment in a bow tie. If you look at if your angle terminates in quadrant 2, then if you want to know this number, which is its reference angle, you would need to take the angle that you started with and subtract it from 180 to get that number, because it's 180 degrees from 0 to here. And then how much is it at the top? Well, that's 90. Okay. So then when you go past the 180 and you're in quadrant 3 terminating, in order to get this number right here, which is with the x-axis, you have to take your angle measure and subtract 180 from it. Make a little sense? Kind of make. And then if you're in quadrant 4, you have to take 360 minus your theta to get this angle right there. All right, so I summarize my picture of this in a bow tie. If you draw yourself an X and Y axis, your reference angles will be in the following positions. If it's in quadrant 1, there's your reference angle right there, and that would be theta, and I'll just use a little tick mark because it's easier to make it than make the hat on here, the little. In quadrant 2, if you terminate, then you would drop a perpendicular to the negative x-axis, and you would put your reference angle here. It's always by the origin. And if you go into quadrant 3 with your theta, your reference angle again is by the origin. And quadrant 4, so this is where, these are where your reference angles are, and it looks like some kind of neat looking little bow tie pattern on it. Yes, theta reference. The reference, this is actually, theta is actually going in this quadrant. That is theta. When it gets in here, that's theta. When it gets to here, you don't have to draw those. That's actual theta, and we get to here, that's the actual theta angle. So if we're going to sketch each angle and find its reference angle, if we're going to do 135, we just have to realize that that's past 90 but less than 180. Yep. So we are terminating with our theta in quadrant 2. That's why we're drawing these yesterday. Ooh, and it's about halfway. Actually, it is halfway. That's 135 degrees, but that's not your answer. You want to find the reference angle. So you want to find theta reference, which would be 180 minus 135, and that's 45 degrees. Okay, the next one, 200 degrees would be past 180, so we're going to be getting into quadrant 3. The reference angle, again, is here with the x-axis. This time it's with the negative x-axis. I want to know that angle measure. In order to get it, I need to take my 200 and subtract 180. So the reference angle for theta is 20 degrees. And now we have one in radians. Since it doesn't have degrees on it, it is radians. We are going to say, well, I'm going to have to, since I haven't learned a whole lot about this yet, okay, we have not learned the unit circle yet, we're going to want to convert this to degrees so we have a better feeling for how big that is, or actually any feeling at this point for how big it is. 5 pi over 3 times the conversion factor we learned yesterday of 180 over pi. If you simplify this, the pi's cancel, 3 goes into 180, 60 times, 5 times 60 is 300 degrees. So now I know it's past the 180, the 90, the 180, the 270, and lands me in quadrant 4. Now, how far into quadrant 4? That's what we'll figure out. So our reference angle right here, we're going to find by doing 360 minus 300. So it would be 60 degrees. All right, so if you want to add those at all to your picture, this angle was 45 degrees, this angle was 20 degrees, this angle was 60. And I didn't draw them necessarily to scale. Did anybody need this still? Okay. I have a mnemonic for you to remember whether things are positive or negative in a quadrant, but it will only apply to the sine, cosine, and tangent. So the little mnemonic is all students, and I'm just going to use an S, take calculus. In quadrant 1, all of the trigonometric functions are positive. I don't like that. I circled those right there. Take that off there. Sorry. The reason being, I didn't mean to imply that that would be circled only in that quadrant. what I'm trying to tell you is that this all students take calculus only stands for sine, tangent, cosine, and all. All of them are positive in quadrant 1. The sine is positive in quadrant 2, therefore the cosecant is, and the rest are negative. The tangent is positive in quadrant 3, and so is the cotangent. The rest are negative. And in quadrant 4, the cosine is positive, and the sine and cosine, and the rest of them are negative. Okay? So we're going to try to find the exact value of each trigonometric function, and we're going to use special right triangles. The sine of 150. Okay, first of all, let's think about where that is, and let's figure out its reference angle. So if we go to the sine 150, that would be in quadrant 2. Its reference angle would be, how many more degrees to get to 180? The easy way to think of it, 30. All right, so let's think about what is the sine of 30, and then we'll decide if this one should be positive or negative. Sine of 30, we're going to get off of a 30, 60, 90. Now, hopefully from geometry, you remember that the short leg we called n. The long leg was n times the square root of 3. And the hypotenuse was 2 times the short leg, 2n. So if you want to know the sine of 30, remember sine is opposite over hypotenuse. That would be n over 2n, using that pattern. And then you would reduce that to, don't forget to replace your n's with 1. That would be 1/2. So the answer to the sine of 150 is 1/2. However, we have to make sure we know whether it's positive or negative. In quadrant 2, all students' sine is positive. So that's the answer. Okay, all students take calculus. Sine is positive in quadrant 2. So we have the right answer. It's 1/2. The cosine of 270. This takes a little practice, guys, so hang in there right now. If I were to go to 270, then I'm actually landing on a quadrantal. We discussed that. Okay, let's call this point on here. If you went down, then that would be the y value, right? The x value would be 0. So let's just make a point on there. 0, -1. That'd be the easiest one. Wouldn't that be like the first nice point on the negative y-axis? Okay, so if you wanted to do that, if the cosine, okay, the r would be 1. You can't really draw a triangle for this, obviously. There's no special right triangle for this. If I want to do the cosine of 270, I have to just know that it is, cosine is x over r, so what's x here? 0. Doesn't matter what the radius is. What am I going to get? Yeah. We want to know those quadrantals, right? The cotangent of 135, that'll put us in quadrant 2 with a reference of 45. 180 minus 135 would give us 45 degrees. So we're going to think about what is the cotangent of 45. Well, we need to know what was cotangent, the reciprocal of might be what you want to think. Tangent? Guys, we should both know that tangent and cotangent are reciprocals. So let's find the tangent of 45. Guess what special triangle you need now? 45, 45, 90. All right, now let's just make up a number. I want to make this a little bit easier. Instead of using n's, how about if we used, made this be, or do you remember the pattern was n times the square root of 2? Yeah, that's your 45, 45, 90. So I will go ahead and use the pattern you learned last year. The tangent of 45, hey, wait, go from a 45. It's going to be opposite over adjacent, n over n, which is 1. So since that one is 1 and cotangent is reciprocal, it would be the same answer, 1. That means that, all right, now we just got to think if it's positive or negative in quadrant 2. All students, the sign's positive, which means the tangent is negative and the cotangent would also be negative. So the answer to this question is the cotangent of 135 is negative 1. So let's think about tangent of negative 30. Okay, now I'm going down 30 degrees. All students take calculus. Well, this answer is going to have to be negative because I'm in quadrant 4, right? Well, we need to find out what's the tangent of 30. So let's go back to our 30, 60, 90. Tangent is opposite. Okay, so let's see. Tangent of 30 would be opposite leg, which would be n, over adjacent leg, which would be n root 3. If I cancel out the n's, I replace them with 1. Okay, so that's 1 over the square root of 3. Yeah, I'm going to have to rationalize it. My pen is doing crazy things. There we go. Okay, we decided it has to be negative. Now we need to rationalize it. So we're going to multiply top and bottom by the square root of 3. It's going to be negative square root of 3 over 3. Just a few more. Tangent of pi over 4. First, you don't know yet that pi over 4 is how many degrees? Anybody know? Well, let's figure it out. 180 over pi is the conversion factor. The pi's cancel out. Try 180 divided by 4. All right, so we're thinking 45 degrees. Means we're in quadrant 1. And that's actually pi over 4 instead of 45. All right, so we're thinking 45, 45, 90 special right triangles. You know what? I can draw it right on here if you want. Remember the pattern? N times the square root of 2. Okay, so tangent is opposite over adjacent. So that's going to be n over n, which is 1. And it's positive because we're in quadrant 1. All right, 4 pi over 3. Now we want to try to think about where that is. So we multiply by 180 over pi. Pi's cancel out. I just thought about something. Pi's cancel out, and then we divide 3 into 180 is 60. 4 times 60 is 240. Oh boy. All right, so let's figure out where that is. 240 would put me quadrant 3. And then I'd have to figure out what the reference angle is. So 240 minus 180 will give me the reference angle, 60. So I need to do the cosine of 60. I'm going to figure out cosine of 60 using special right triangles. I'll just remind you of the pattern. 60 is on opposite the long leg. That's n root 3, n, and 2n. So if the cosine of 60 is adjacent over hypotenuse, that's n over 2n, which is 1/2. Now, we got to remember what quadrant we're in. So, cosine 4 pi over 3. All students take. Tangent's positive in quadrant 3, so this has to be negative 1/2. There's finally got our answer. Takes a little effort. Negative pi. Oh dear. Well, pi times 180 over pi is how much? 180. So actually, negative pi is the same as negative 180, which would be here, right? Okay, so that point's going to be negative 1, 0. And let's think, what's cotangent? And r would be 1. Tangent and cotangent are, tangent is y over x. So it'd be 0 over y over r, actually y over x, 0 over negative 1. So this would be negative 1 over 0. Oh, hang on. You're tempted to say 0, but are you allowed to divide by 0? It's undefined, okay? So when you get that, you write undefined, UND. Okay, and the last example for today, negative 3 pi over 4. Where would that be? So convert it back to a degree answer. Let's see, that's a negative 45 times 3. What's that, 135? Negative 135 degrees? All right, that puts me here. And then to get to the x-axis, I would need 45 degrees more. So it's a 45, 45, 90 special right triangle we need. N times the square root of 2. Okay, so if we're doing the sign of that would be n over n root 2. Sine 45 is going to be n over n root 2. We're going to simplify that. That'd be 1 over the square root of 2. We rationalize that by multiplying top and bottom by the square root of 2. We get the square root of 2 over 2. Now, all students take tangents positive here, so this answer actually should be negative. Thank you. That was a lot. Now you need some ice cream, right? No, they're gonna have to listen, and I'm gonna have to do some more examples, most likely. Thank you.